There's a large gap between fundamental research findings and an actual drug. And the purpose of the Barry Sherman Institute for Medicinal Chemistry is to bridge this gap.
I love coming into the lab every day and find out if new compounds that we made are actually working. We're making new materials that were never synthesized before by nature, and so every day there's a potential to discover something new.
What the Institute intends to do is to foster fundamental research into finding a lead drug or an actual drug that can be used later in the clinic, and also to foster collaborations between biologists, chemists, and computer scientists to talk about a specific problem that one of them, for instance, is facing, and another can say, oh, this problem, we have a solution ready-made in our lab.
We have discovered a new compound that is able to bind to a protein called p53. It's also known as the guardian of the genome. It's a very important gene to protect people against cancer. Many cancer patients, this protein is not working correctly, and our compounds try to correct that protein and thus kill the cancer cells specifically. Such compounds can one day turn into personalized therapeutics for cancer patients.
A few years ago, a new faculty member joined the department, Netare Gavrutsky, and she works on malaria. So over coffee, we got together and I asked her what's new in the field of malaria immunology and whether there's any molecule of interest in that field. And she said that, in fact, very recently, a new molecule was discovered and characterized that can have huge potential as a vaccine for malaria, but this molecule is notoriously unstable. At the time, we just developed a method to stabilize notoriously unstable biological molecules. So we applied our method to the malaria protein. And this design protein is now being used in clinical trials. These collaborations can make the breakthroughs that enable the next generation of drugs.